This problem is starting us with an equation here. So f of x equals x cubed plus 3x. But notice that what they're asking you for, they're wanting you to find the derivative, not of that specific function, but with that function having the natural logs plugged into it. So what we're looking at is a composite function here. We need to first go find that composite function so that we can take the derivative of it. So if we've got f of x is equal to x to the third plus 3x, and then they're asking us to find f of the natural log of x. Remember, this is just function notation, right? They're telling us no matter what I replace x with inside those parentheses there, you take that thing, whatever it is, and you replace every x in the equation with that in parentheses. So here, I'm going to plug in, instead of x, I'm going to have the natural log cubed plus 3, and then again, instead of x, I'm now going to have the natural log of x. So I always start by just sort of plugging it in and seeing what it looks like. Now this is what we're being asked to find the derivative of. That's what they're asking us to find the derivative of now, which is a bit different than where we started. Whenever you see a derivative problem, you're always going to break it down into bite-sized chunks by the pluses and the minuses. So we've got that piece is its own derivative, and then this 3 natural log of x is its own derivative. Going to look at this first part here, trying to build my derivative, looking at this piece here, if you just kind of pull it off to the side, so we're looking at the natural log of x to the third. Well, that is a classic of all classic chain rule setups. If you look down on your page and you see that you've got some equation inside of parentheses raised to a power, bells and whistles got to be going off that this is going to be a chain rule problem. And that's what you'd be looking at here. My chain rule saying that I use goes d in times d out. I always want something simple and easy to remember. So what this is saying is take the derivative of whatever's inside those parentheses, and then multiply it by basically a big power rule in this situation, whatever is happening outside here. So to build this, our inside piece on this is the natural log of x. Well, that's just kind of adding in one little layer here. The derivative of the natural log is what I call a special case derivative. Special case derivatives are just derivatives you have to have memorized. And if you don't have them memorized, you're probably never going to guess it. And so here our original function is f of x equals the natural log of x. The derivative of the natural log of x would be 1 over x. So finding the derivative of our in right now, finding the derivative of the natural log of x, that d in would be 1 over x. Then we would multiply it by the derivative of the outside. So the d out. The derivative of the outside here is this power of 3 that you would just be bringing down in front, and then you'd be leaving all the other stuff alone, subtracting 1 from the power. This is really just a big power rule that you're doing here on the d out. So bring the 3 down in front, leave all the stuff alone we already took the derivative of, subtract 1 from the power. So then adding that into the mix over here, we have 3 natural log of x, and then that whole thing is squared. Then we're done with that piece. So that was our chain rule for this first one. And now we're going to go look at the second one. So we'll get plus, and here we're just looking at a straight 3 times the natural log of x if you simplify that down. So this is, to get this derivative, this is just a straight up special case exactly how it is. The number up in front, numbers come along for the ride, remember, so don't overthink this. This is just going to be 3 times the derivative of the natural log of x would be 1 over x. And so out of there we would be looking at 3 over x. So then we put that in here as the derivative of our second piece. At this point, right, you stop. I always tell people, don't go any further, right? Once you've taken the derivative once, kind of look at your answers and see what's happening. And you sort of look around and say, okay, they want me to simplify this a little bit. Well, all right, let's see what I can do. Look for some straightforward stuff. So I have 3 times 1 over x. That's really a 3 over 1. So we multiply the top with the top and the bottom with the bottom. So that's 3 over x, and then that natural log of x squared is also on top with the 3. So this would be 3, and then the natural log of x squared. And then we have our second piece, which is 3 over x. Again, pause for a moment, kind of take a look at your answers, and you don't quite see what you need. Then what you want to do is look to combine those two fractions. Whenever you've got two fractions, that would be sort of your next move out of here. Luckily, in this situation, you should see that you already have the common denominator made, or else you would have the pleasure of doing that. Here we avoid that, and so we can just bring these together as a single fraction over our common denominator, which is x. And again, stop and go look, and this time you can see that your answer matches with A. So a lot of times on these tests, you take your derivative, put the pieces where they belong, and then the manipulation, they call it simplifying, but it's just you're manipulating the equation as far as they want you to go before you can find your matched answer. You just got to be open to doing some of that algebra at the end. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.